Now let's do a question in which we have to arrange this in increasing order of the absorbance or intensity. First we have COH2O whole 6 2 positive. So in COH2O whole 6 2 positive, CO is in +2 oxidation state, that means it is Ar3d7 and 4s0, and it is a high spin complex because CO in 2 positive state with H2O, H2O is going to act as a weak field ligand. So this is Eg, T2G. So 1, 2, 3, 4, 5, 6 and 7. It's going to be a DD transition, and DD transition, it's an octahedral complex. In octahedral complex, DD transition is Laporte forbidden. So I am not seeing the Laporte one thing because the Laporte is already forbidden for this. This is Laporte forbidden. We are trying to see right now if it's going to be spin allowed or not. This electron, that is the electron which is already paired up, that is going to go into the Eg. This electron cannot go to the Eg because then it will violate rules. So only this electron can go into Eg. So we have 1, 2, 3 and 1, 2. That is any of the paired electrons. This paired electron or this pair of electron, this can go to the Eg, but the single unpaired electron, this itself cannot go to the Eg. So now let's calculate. So for this, the S1 is equal to, here we have plus half minus half, so 0, plus half minus half, so 0, plus half, okay, this is just plus half, plus half, plus half. So overall is 3/2. For this, plus half minus half 0, plus half minus half 0. So the delta S2 is going to be plus half, plus half, plus half because of the 3 unpaired electrons. That is going to be 3/2. So delta S is equal to 0. So it's spin allowed. Now let's do for CrO3. In CrO3, chromium is in +6 oxidation state because oxygen is -2. Chromium plus 2 into -3 is equal to 0. So chromium is in +6, and chromium in +6 means that its electronic configuration is Ar3d0, 4s0. There are no electrons present in your d orbital. So how will the transition take place? The transition is going to take place from the orbitals of the oxygen to your chromium. Oxygen is O2 negative. O2 negative means it is 2p6, 2s2, 2p6. Originally it was 2p4. 2 electrons have been added, that makes it 2p6. So if this is the 3d0 and this is the 2p6 of oxygen, 1, 2, 3, 4, 5, 6, then after excitation, one of the electrons from the 2p6 can go to the 3d0 of chromium. Okay, let's say this electron has gone. Now this is Laporte allowed because the transition is happening from P to D. So the delta L is equal to 1. So it is Laporte allowed, it is spin allowed also. If you calculate, you will be able to see it is spin allowed also. So CrO3 is Laporte allowed as well as spin allowed. Next we have Vcl4 negative. Vcl4 negative. In this, vanadium is in +3 oxidation state. So if it's +3 oxidation state means its electronic configuration is Ar3d2, 4s0. Now it's 3d2, so yes, transition can happen from D to D, but that should be Laporte forbidden. But this is not an octahedral complex. This is a tetrahedral complex. So if it's a tetrahedral complex means it is going to be Laporte partly allowed and it is also going to be spin allowed. We already saw that D2 was spin allowed. So it is going to be spin allowed also. Next we have TiCl6 2 negative. So in TiCl6 2 negative, titanium is present in +4 oxidation state, which means that the configuration of titanium 4 positive is 3D0, 4S0, and chlorine negative is 3S2, 3P6, because chlorine was 3P5, and if there is one negative means one electron has been added, so 3P6. So the 3D0 and we have 3P6 of chlorine. After excitation, one of the electrons can go into the 3D0. So this is going to be Leporte allowed as well as spin allowed, because here you can see the spin is going to be plus half minus half 0, cancel each other out, plus half minus half cancel each other out, plus half minus half cancel each other out. So here also S1 is equal to 0, and here plus half minus half cancels each other out, plus half minus half cancels each other out, plus half minus half cancels each other out. So S2 is equal to 0. So for this, delta S is also equal to 0. So this is Leporte allowed as well as spin allowed. The last one that we have left is Mn NH3 whole 6 2 positive. So we know that Mn here is 2 positive, so that means its configuration is Ar3D5, and here the Mn is in 2 positive state, so NH3 with a 2 positive metal cation is going to act as a weak field again, so it will be high spin, that is D5 high spin. We have already seen that D5 high spin is spin forbidden, and because this is an octahedral complex, so DD transition is also forbidden, so it is also Leporte forbidden. So on the basis of this, we can say that the color of the Mn NH3 whole 6 2 positive is going to be the least. Then we have the color of your CO H2O whole 6 2 positive. After that we have Vcl4 negative, and then the color of CrO3 as well as TiCl6 2 negative is going to be equally intense. So this is the increasing order of the intensity of color. So this is how you can predict whether a complex, which complex is going to be less intense in color and which complex is going to be more intense in color.